Right. So we started talking on Monday about biodiversity through time. Uh, there aren't just 1.9 or so million known species of animal, plant, protist, fungus, and bacterium on Earth. That is, as it were, the tip of the iceberg. There have been countless millions of species in the past. And you can't fully understand life today without understanding life's history. We still have to know something about dead biodiversity. We talked about Steno, this guy who worked out some rules of thumb for how sedimentary rocks formed. Those are the rocks that are laid down by water or by air that come in layers. Virtually all of the rock in Arkansas, by the way, is sedimentary. We don't have very much rock that formed from lava, except for Crater of Diamonds and those rock crags that you see just south of Little Rock, from the south end of Little Rock all the way to exit 3 on Interstate 530 / US 167. All that stuff around the Dixon Road exit is not sedimentary, but almost everything else is. Certainly all of the Ozarks and the Ouachitas are. And we talked about William Smith, who realized that different rock layers contain different fossils, and the order of appearance in time of those fossils was the same over a wide area. That's Smith's law of succession. One more dead white guy I want to introduce you to was a Frenchman by the name of Georges Cuvier. He became the professor of comparative anatomy at what used to be the King of France's personal collection of cool stuff. Now, France, if you remember, got rid of their king and, in fact, chopped his head off. And the king's former collection of cool stuff became the Museum of Natural History in Paris, still there, worth a visit if you're ever down that way. And he spent more time looking at animal bones than just about anybody, both living animal bones and dead animal bones. And take this is a jawbone, for example. This particular one is not one that Cuvier personally studied. It's actually from a small museum out in a little town called Shoshone in the Mojave Desert of California. But Cuvier studied jawbones that were very like this. This is actually a very big jaw. This is probably been a while since I've seen it, but it's maybe a little less than a meter across. A meter's a yard plus a little bit. It's only got 2 large teeth, but you can see those kind of up towards the front. Those things with, okay, there we go. Those things with the little ridges on them, those are molar teeth.
Those things with little ridges on, those are molar.
Okay, Jeffrey, mute your mic if you would. Okay, you did.
Sorry about that.
Quite all right. So this is a very large jaw, and the parts that attach to the skull are those parts in the back. And Cuvier studied jawbones that looked a lot like this. Cuvier didn't discover these. These had been known for quite some time. And people called them the bones of mammoths. And that's Cuvier's original drawing of a mammoth lower jaw. You can see it's got 2 really big molars and no other visible teeth. And the molars have these ridges on them. That's those parallel lines that you can see. I don't know if you can see my arrow, but those ridges right there, those are the molars. And he compared mammoth jaws with the jaws of living elephants. This is his drawing of an Indian elephant jaw. Clearly, they're very similar. They've both got this, U-shaped pattern with only two molars in the jaw at any given time, and the molars have these ridges on them because elephants eat a lot of rough vegetation, grass and tough leaves and branches and things like that. So they have big grinding teeth. And Cuvier showed that they were very similar, but not identical. There were consistent differences between the bones of living elephants. Cuvier was working in one of the few places where he had access to those. There were consistent differences between the bones of living elements and these fossils that people were digging up. And this was strange because mammoths are in fact the size of elephants. There you've got a mammoth skeleton on display at a nice little museum in Western Kansas, worth looking at if you ever visit the town of Hayes. And Cuvier argued that if mammoths were still alive, we'd have found them by now. Mammoth bones turn up in Europe, in Asia, in Siberia, in North America, and they're huge. There's not that many places you can hide a herd of elephants. And Cuvier argued that if mammoths were still alive, we'd know it. And his conclusion was that the mammoth must have, dun, 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 gone extinct. This doesn't seem really earth-shaking, probably because, you all grew up, I'm sure you've all seen Jurassic Park. If you were anything like, especially my sister, maybe you played with dinosaur models as a kid or read your dinosaur books or something like that. You're used to the idea that there once were living things on Earth that aren't there anymore. That Tyrannosaurus Rex is gone forever and we will not see it again. That's not really strange. It was kind of strange back then, and it bothered some people because it raises the question of where did they go? What happened to mammoths, which must have once roamed large parts of the earth in considerable numbers? Cuvier studied European mammoths, but I might add that about the time he was doing his work, giant bones were also turning up in North America as the settlers and colonists started pushing west away from the Atlantic coast. And there were a lot of mammoth and other bones of extinct critters being found in a place in Kentucky. Now that place is a natural place where there's salt in the soil. So it's a place where deer and then later cows and things would come to lick the salt because they need it. And then big bones turned up. And to this day, you can visit Big Bone Lick in Kentucky. But I don't know, I just kind of like the name. Anyway, Cuvier studied species after species and concluded the same thing. Cuvier studied a giant European deer, which is now commonly called the Irish elk, even though it's not technically an elk and it's not only found in Ireland. Male Irish elk, if you were to shoot one of these things, the Boone and Crockett Club would put up a damn statue to you. They have enormous antlers. Cuvier, they were already discovered, but Cuvier was the one that showed point for point that these bones did not belong to a reindeer, a moose, a springbok, or any species that was still alive and could still be found. And he kept making that discovery over and over again. He made the conclusive case that extinction happened. And while this doesn't sound revolutionary now, at the time, it was downright scary. You know, what could have gone wrong that would wipe out something as big and imposing as mammoths and Irish elk, and dinosaurs and things like that. Cuvier also realized that the older the fossils were, remember, we've got Steno and Smith that were able to show that fossils appear in an order in time. Cuvier showed that the older the fossils were, the less familiar they looked. Up there at the top, that's in that museum collection in Kansas. We used to have these running around North America. Those are longhorn bison, and they're not grossly different from the bison that we have now, you know, buffalo as we call them, although they're not the same as African buffalo. So this is a lot like living bison. It just happens to have longer horns, but it's still pretty familiar. Look in older rocks and you start finding things running around North America like titanotheres, which look like rhinos with forked horns, like a rhinoceros crossed with a slingshot. And if you go far enough back in time, you start finding things that look completely bizarre. That's the head of a creature called an ichthyosaur, which looks vaguely like an alligator pretending to be a dolphin. Nothing like that is around, nor has been for a very long time. The older the fossils get, the less they look like anything familiar. And people started accepting the idea that the Earth was really, really old, especially as things like this start turning up. At the time in European history that I'm talking about, women were not generally allowed to be scientists. So I don't have a lot of people to mention just yet that are not dead white dudes. But I can mention Mary Anning. She was a professional fossil collector who took up fossil collecting as a way to earn some money after her husband died. And she ended up being the one that made some pivotal discoveries. She dug this thing up in the south of England at a coastal town called Lyme Regis. It's called a plesiosaur. It's been compared to a snake that's been strung through the body of a turtle. It's got kind of a roundish body, but a long snaky neck and 4 big flippers. Nothing like this is around today. I mean, maybe the Loch Ness Monster, but I probably not. I'm skeptical about the Loch Ness Monster. So more and more and more fossils keep turning up of extinct critters that don't look anything like what we'd see now. And it gets harder and harder for people to argue that this growing diversity of unfamiliar life forms could be crammed into just a few thousand years. And that's why by about 1830, I said 1850 in a previous slide, but the idea is growing even farther back than that. The message is getting clear that life on Earth has a history. It's changed over time. It did not used to be what it is now. It probably won't be the same in the future to what it is now. That history is probably really, really long, and you cannot fully understand life today without knowing that history, just as you can't understand, you know, the unique screwed up ways of the United States without knowing something about how we got that way. I'll fast forward a little bit to 1910. This gent is an undergraduate at the University of Durham in Northern England. His name's Arthur Holmes, and he's still an undergrad. You know, what have you done these lately? Just kidding. Worked out a way back in 1910 to use natural radioactivity as the way that we could figure out the age of the Earth and the rocks on it. By the way, just a disclaimer, when I talk about scientists of the past, the only detail I'm really going to ask you for on the exam is going to be last names. Don't try to memorize birth dates and death dates and things like that. Focus on the ideas that they did. You know, birth and death dates and interesting life experiences you can always, you know, look up. That's why the gods gave us Wikipedia. Focus on the ideas. So what was Holmes's idea? Okay, you hear a lot about radioactivity. If you've got a decent chemistry background or physics background, you probably know this already. But suffice it to say that atoms of a radioactive element give off energy in various forms, and as they do, they turn into different elements. We call this radioactive decay. Up at the top left, there's a gray octagon with the letter U in it. Up at the top and over on the left side, that represents an atom of the chemical element uranium. If you have an atom of uranium, specifically a type called uranium-238, and you sit around and stare at it long enough, eventually that atom will spit out a little energy in the form of what's called an alpha particle, and it will turn into an element of a different type. It will turn into an atom of the element thorium. And then if you stare at that thorium long enough, it will spit out a little energy in the form of a beta particle and turn into an atom of an element called protactinium. Protactinium will turn into uranium again. Uranium turns into thorium, turns into radium, turns into radon. Given enough time, that atom of uranium will eventually turn into an atom of lead. And after that time, it doesn't change any further. Lead is stable. Lead atoms will be around for as long as there's a universe worth talking about. Okay, so that's how radioactivity works. And you hear about radioactivity and radiation often in technological contexts like nuclear weapons or nuclear power plants or things like that. But most rocks have at least small amounts of radioactive elements that occur in them naturally. And once a rock forms, the radioactive elements in the rock will decay into other elements, and we measure the rate using a length of time called a half-life. And yes, I know that's an award-winning video game, and one of my old high school friends was actually a programmer on it, by the way. One of my few brushes with greatness there. Okay, yeah, great game. And yeah, one of my old high school buddies is a guy named Jay Stelly, who went on to be a programmer, and I think he worked on Half-Life and BioShock, but not relevant here. Anyway, a half-life is the length of time it takes for half of a sample of atoms to decay. So if I have a big lump of pure uranium-238, half of it will have decayed in a length of time. And in two of those lengths of time, half of what's left will have decayed and only a quarter will remain. And after another half-life, only 1/8 will remain. And then after yet another half-life, 1/16 will remain, and so on. A half-life is the period of time that it takes for 1/2 of any sample of a radioactive element to decay. I always think of this as being kind of like watching the crowd after a football game. You know, in any given football game, there's people that run for the exits the minute the whistle's been blown, and there's people that like to hang out afterwards, or people that don't like dealing with the crowd pushing its way through the gates. And then, of course, those gates only allow a certain number of people through at any given time. So if you were up in the Goodyear blimp watching a football game, you'd see the final whistle blow, people start leaving, and after, let's say, 10 minutes, maybe the stadium is only half full. But then after another 10 minutes, half of those people would be left and the stadium might only be a quarter full. And then after another 10 minutes, half of those people had left and the stadium's only 1/8 full, and so on until maybe after an hour and a half, nobody's left except a couple of drunks and the cleaning crew or something like that. That's kind of my personal metaphor for trying to illustrate half-lives. And if you can measure the amount of radioactive elements in a rock, and you know the half-life of its decay, you can do some algebra and work out its age. This does not work for every rock. It only really works well for igneous rocks, rocks that used to be molten, rocks that used to be so hot they were a glowing liquid, the kind of stuff volcanoes put out. But Holmes's first attempt to do this found rocks that were as old as 2 billion years. Since that time, we found even older rocks. The oldest in the solar system date to approximately 4.6 billion years old. Let me put that in a concrete way. Imagine that the length of time that the Earth has been around is equal to the length of a 1,000-sheet roll of toilet paper. You could fit all of human history, everything from the pyramids to today, onto the little fuzzy fringe at the end of the last sheet. That's what kind of length of time we're talking about that the Earth has been in existence. It's kind of a lot. We've gotten a lot better than we were in 1910 when Holmes was working at measuring those rates, at calculating the half-lives, and basically you do this by counting atoms. And it's very hard to count atoms because they're kind of small and they tend to get lost between the seat cushions. But we've gotten a lot better at using gizmos like this shrimp. Shrimp is, what's that? Super high resolution ion microprobe. This is basically an atom counter. And we've also come up with various ways that we can cross-check radiometric dates. There are things that will make a date calculation inaccurate, but we've got various ways of testing for those. We don't really have time to go into detail as to how that's done, although here, if you're curious, Wikipedia gives a pretty good introduction. What I want you to know is that we can calculate the age of at least some rocks by using naturally occurring radioactivity. We call this radiometric dating. And I just want to remind you that, of course, this is why you should never trust an atom. You know why you should never trust an atom? It's because they make up everything. Okay, just checking to make sure everybody is listening. Okay, right. Stepping out of the modern age back to 1831. Just sit right back and you'll hear a tale of a fateful trip that started from London, actually, aboard a tiny ship called Her Majesty's ship Beagle. The British Navy was doing a lot of surveying expeditions at the time, for the simple reason that if you're going to have a navy, you've got to have very accurate maps and charts. Otherwise, your very expensive warships are going to crash into rocks and sink. which is not really a good thing. So the Navy was sending out a lot of small ships, not the huge warships of the time, kind of the Ford Ranger of the day, that were going around and charting coastlines and measuring the ocean depths and finding the best routes for sailing. And this was just one of them. And this guy, Captain Fitzroy, was preparing for a voyage to South America that would, he estimated it would take about 3 years. It ended up taking about 5. Fitzroy, of course, needed, good instruments for navigation and for mapping. It's not that easy to draw accurate maps from ground level, but Fitzroy knew how to do it. And of course, he had sailors to sail the ship and, officers, and, there was a ship's doctor and an artist, no photographers back then. And he wanted to bring someone along who could describe and study the animals and plants and rocks and things like that of South America, because knowledge like that might be of military use. If your ship is sailing the waters of South America and the mast falls down, you might want to know where you can get trees that are suitable for making a new one, or where you can find, what animals you can shoot for your food, things like that. So to make as complete a picture as possible of the countries he was going to be exploring, he asked around for somebody who was trained to describe and study animals and plants. One of his friends was a professor at Cambridge University in England. Not that you need to know, his name was John Henslow. And Professor Henslow just happened to tell Captain Fitzroy about a student of his. This is he, as a young man. He just graduated. He was actually got a degree in theology and was preparing for a career as a minister in the Anglican Church, AKA the Church of England. The branch of that church in this country is known as the Episcopal Church, if you didn't know. But we have, members of, we have this church in America, it's just under a different name. Anyway, this guy was about to become a minister, but he'd taken a lot of classes in biology and geology and was quite knowledgeable. Most importantly, he was a really nice guy and easy to get along with. This is important because the ship is only about 100 feet long, and it's going to be housing 90 people, all men, mostly young men, who are going to be living right on top of each other and smelling each other's feet and working very hard physically in dangerous conditions for weeks on end. And if you're going to be living in that kind of a pressure cooker, it really helps if you get along well with people. And fortunately, our young hero got along very well with people. All of the accounts of his life basically say that he was a really nice guy. So Her Majesty's ship Beagle left England on December 27th, 1831, with a fellow by the name of Charles Darwin on board, or as I like to call him, Chuck D. They reached South America in 1832 and spent the next 3 years going up and down the coast of South America, charting that coast, drawing maps. Maps, by the way, that were so well done that the British Navy continued using them up until the 1950s, when it became possible to draw maps using satellites. But yeah, Fitzroy really did his job well, was an excellent map maker. We don't have time to discuss everything that Darwin saw and did on this voyage, which would end up lasting nearly 5 years. There's the Beagle. They're encountering there. Those are the indigenous people of the southern tip of South America in those little boats. The Yamana people are the southernmost of all Native Americans. His diary he eventually published. Its title is now Voyage of the Beagle, and you can read it if you want to, if you like accounts of voyages of sailing ships and things like that. We don't have time to go into anything like the full story, but I'll focus on just one brief episode that was important. They'd spent 3 years exploring South America. They got home by sailing up the Pacific coast, and they stopped for food and water at a grouping of tiny little islands that look like this. These are 600 miles off the coast of Ecuador, and they're called the Galapagos Islands. So there's a fairly typical view of the Galapagos. There is most of the islands are now a national park and strictly protected. There are people that live there. In fact, there's a town of about 20,000 people in the Galapagos. And I've actually met the guy who used to run the only pizza parlor in the Galapagos. That certainly didn't exist when the Beagle visited in 1835. No pizza. This is what there was. The Galapagos are volcanic, and eruptions still happen to this day. The last major one was in June of 2018. There were a few little lava flows about a year ago. They still do rumble a bit now and again. What you're looking at here is lava, molten hot liquid rock that cooled, and you can see it cooled in kind of a sort of smooth, ripply shape. If you've ever poured fudge into a cold pan, you might have seen a similar pattern. They're small, they're still erupting. Relatively speaking, they're a lot younger than the mainland of South America. These have not been around for very long. They're still in the process of formation. All of the fossils that you find in the Galapagos are very much like living organisms. And what Darwin noted was that Galapagos wildlife included a lot of species that were unique to the Galapagos Islands. Here's Buteo galapagoensis, the Galapagos hawk. Now that's in the same genus as birds that you could see around here. I see red-tailed hawks. Actually, they fly over my house now and again. I'm far out enough in the country that they've got some good hunting territory out here. And those are in the same genus. Those are Buteo jamaicensis. The red-shouldered hawk, a couple of years ago, there was a whole family of them living along the Tucker Creek Trail close to Salem Road. We had them in the city limits. I forget what the red-shouldered hawk is, but that's also in genus Buteo. All the same, the Galapagos hawk is a separate species. It's different enough from the red-tailed and red-shouldered hawks that we classify it as a different species, Buteo galapagoensis, and it's only found in the Galapagos Islands and nowhere else in the world. The same is true for the Galapagos penguin, Spheniscus mendiculus. Similar to South American penguins, there's something like 20 different species of penguin. They live in the southern hemisphere. There are South African penguins. Bianca, I don't know if they get up to Namibia, but maybe they do. There are Australian penguins, there are South American penguins, and the Galapagos penguin looks a lot like South American penguins, but it's still unique to the Galapagos Islands. It's only found there. The only penguin that lives on the equator. There were a couple of species of iguana in the Galapagos, big lizards. Very odd habits. This iguana sits on rocks and warms up in the sun. When it's warm enough, it will jump right into the ocean and swim around and eat seaweed. That's kind of a weird thing for a lizard to do. Lizards you don't think of as being able to swim in the ocean and live on seaweed, but this one does it. It is similar to South American iguanas from the mainland, some of which you could actually find in a pet shop. But this particular species, Amblyrhynchus cristatus, is unique to the Galapagos. There are 3 species of mockingbird that are unique to the Galapagos. 6 species of prickly pear cactus, a species of wild tomato. There must be dozens of species of living thing that look like critters you would find on the continents of South America and North America, but they're not the same, and they're unique only to the Galapagos Islands. Probably the most famous Galapagos life forms are a group called the Galapagos finches. A finch is a type of seed-eating bird. You know one finch very well. It's the cardinal. I know you've seen cardinals around here, the bright red birds that we see. That's a finch. We have purple finches and some other finches in Arkansas, and there's 14 different finches living in the Galapagos Islands. This just happens to be one of them, the small ground finch. And here was what's weird. Different species of finch turn up on different islands. And all of the species, although they're clearly finches, each one has a distinctive way of life, and each one shows what we call adaptations to that way of life. Each one has physical features that make that finch able to make a living in a particular way. And the easiest place to see this is the beak. The small ground finch feeds on small seeds, and it's got a small beak that's not very strong, but is good at handling tiny objects. The cactus finch, Geospiza scandens, long, narrow beak that's very good if you're eating seeds and fruits of a plant that's got great big spines. The large ground finch, big seeds, and it's got a big beak that can exert a lot more force to crack large seeds and get the edible parts inside. They're all finches. They've all got a common structure, and yet each one is adapted to a different lifestyle and reflects those adaptations in their physical structure, most obviously in the beak, sometimes in other parts as well. And again, we get the same story. The Galapagos finches look like South American finches. This is one of them, a South American finch called the black-faced grassquit, Tiaris bicolor, but they're not the same. They're unique to the Galapagos. They're only found there. And it makes you wonder why. Why should the Galapagos have finches with great big seed-cracking beaks like a parrot, but not have any parrots? Why should the Galapagos have birds with long beaks that probe in rotten wood for bugs, like woodpeckers, and yet not have any woodpeckers? And what the hell is it with a finch that makes a living by hopping up behind larger birds, stabbing them in the butt with its beak and drinking their blood? Like, who came up with a blood-drinking finch? It's called the vampire finch. As Darwin wrote, seeing this gradation and diversity of structure, one might really fancy that from an original paucity of birds in this archipelago, one species had been taken and modified for different ends. What the heck? Um, you could almost imagine that there had originally been very few species of birds in the Galapagos. Paucity means very few. And one species had somehow produced the 14 that you saw now. Huh. Interesting idea. Let's hold that thought. I will stop the recording now and we'll pick this up on Friday.